Hi friends, welcome back to Science Chapter 2, Acids, Bases and Salts. In this video, we will cover the chemical properties of acids and bases. In the previous video, we have seen the physical properties of acids and bases. So we have seen that acids are the chemical substances which are sour in taste. For example, lemon. Have you ever tasted lemon? It is sour in taste as it contains citric acid. And we have also seen that the acids are corrosive in nature. So acids cause severe burns on the skin if they come in contact with the skin. But this is a definition based on the physical properties of the acids. So now let us see how we can define acids chemically. So let us understand this by an example. So we dissolve hydrochloric acid in water. So when we dissolve hydrochloric acid in water, it splits into its ions. That is, HCl forms its ions, H positive ions and Cl negative ions. Similarly, if we dissolve sulfuric acid, that is H2SO4 in water, it also gets split into its ions and it forms H positive ions and SO4 2 negative ions. Now can you find something common in this? Yes. Both of these acids, when they split into their ions, they form H positive ions. So this means that acids are the substances which when dissolved in water give H positive ions. Or acids are the substances which when dissolved in water give hydrogen ions. But it is important to note that hydrogen ions cannot exist alone and they can only exist after combining with the water molecules. So therefore, when we represent hydrogen ions in the form of equation, then we always must write hydrogen ions as H positive aqueous or H3O positive, which is hydronium ion. Now let's see the types of acids. So there are two types of acids based on their source from which they are obtained, and they are organic acids and mineral acids. Organic acids are the acids present in plants and animals. So they are obtained from plant and animal sources. While mineral acids are the acids present which are prepared from the minerals present in the earth. Now let's see their examples. For mineral acids, the examples are hydrochloric acid, sulfuric acid and nitric acid, etc. And for organic acids, we have various examples such as in vinegar, acetic acid is present, in orange and in all citrus fruits, in all fruits which are sour in taste, citric acid is present. In tamarind, that is imli, tartaric acid is present. In tomato, oxalic acid is present. In sour milk or curd, lactic acid is present. And in lemon again, citric acid is present. And in ant sting, methanoic acid is present. And similarly in nettle sting also, methanoic acid is present. Now let us understand the chemical properties of acids. So there are four properties: reaction of acids with metals, reaction of acids with metal carbonates and metal hydrogen carbonates, third, reaction of acids and bases, and fourth, reaction of acids with metal oxides. So first let us see the reaction between acids and metals. So to understand this, let's conduct an experiment. So in a boiling tube, take dilute sulfuric acid and add zinc granules to it. So sulfuric acid is an acid and zinc granules, zinc is a metal. Now take soap solution in a trough and join it to the boiling tube with the help of a glass delivery tube. Now as you know that we have an acid and a metal, so obviously a reaction will take place between the zinc and sulfuric acid, and during this process we observe that a gas is formed, and this gas results in the formation of bubbles of the soap. So we had taken a soap solution in the trough, and when this gas passes through a glass delivery tube and reaches a soap solution, then bubbles of a gas is produced in the soap solution. And when these bubbles rise out of the soap solution, then to test which gas is present, then we will bring a burning candle near the soap, near a gas-filled bubble. And we observed that the candle burns with a pop sound. Now do you remember that pop sound is a characteristic of which gas? Yes, it is a characteristic of hydrogen gas. So from here we can confirm that when zinc and sulfuric acid react, then hydrogen gas is formed. So in general, we can say that acid plus metal results in salt plus hydrogen gas. So for the above reaction, the equation would be zinc plus sulfuric acid is equal to zinc sulfate plus hydrogen gas. So in the form of symbolic equation, it will be Zn plus H2SO4 results in ZnSO4 plus H2, and zinc sulfate is nothing but a salt. Second, now let's see the reaction between an acid and metal carbonate or metal hydrogen carbonate. So acid plus metal carbonate or metal hydrogen carbonate results in formation of salt plus carbon dioxide plus water. So let's see with a few examples. First is Na2CO3 plus 2HCl results in 2NaCl plus CO2 plus H2O. So this means that sodium carbonate plus hydrochloric acid results in the formation of NaCl plus carbon dioxide plus water. And similarly, we have another example. So that is sodium hydrogen carbonate plus hydrochloric acid results in the formation of NaCl, which is a salt, plus CO2, which is a carbon dioxide, and third, water. Now let us see the reaction between an acid and a base. So we have already discussed this in the first video. So when an acid and base react, then this neutralizes the effect of both the acid and base, and a salt and water is formed. So this reaction between an acid and base to give a salt and water is also known as neutralization reaction. For example, sodium hydroxide plus hydrochloric acid results in the formation of NaCl, which is a salt, sodium chloride, and water. So now fourth, reaction between an acid and metal oxide. So metal oxide plus acid results in salt and water. So this is similar to the third reaction. And for example, CuO plus 2HCl results in formation of CuCl2 plus H2O. So CuO is copper oxide, which is a metal oxide, and HCl is hydrochloric acid, and CuCl2 is copper chloride, and copper chloride is a salt, and H2 is water. So now let's revise whatever we have learned till now. First, metal plus acid results in formation of salt plus hydrogen gas. Second, metal carbonate or metal hydrogen carbonate plus acid results in formation of salt plus carbon dioxide gas plus water. Third, acid plus base is equals to salt plus water. And fourth, acid plus metal oxide results in formation of salt and water. So now we have come to bases. So in the previous video, we have seen that bases are the substances which are bitter in taste. There are substances which are soapy to touch, and bases which are soluble in water, they are known as alkalis. But now let's define the chemical definition of bases. So for this, let's conduct an experiment. When sodium hydroxide is dissolved in water, it splits into its ions, and these are Na positive ions and OH negative ions. Similarly, when potassium hydroxide is dissolved in water, it splits into K positive ions and OH negative ions. So in both of these cases, what is common? Yes, both of them divide into OH negative ions. So from here we can define bases as bases are the substances which when dissolved in water give OH negative ions, or bases are the substances which when dissolved in water give hydroxide ions. So now let us see the chemical properties of bases. First is reaction of bases with metals. So metal plus base results in formation of salt and hydrogen gas. For example, when sodium hydroxide solution is heated with zinc, then sodium zincate and bubbles of hydrogen gas are formed. To represent in the form of equation, we can say that 2NaOH plus Zn in the presence of heat results in the formation of Na2ZnO2 plus H2 gas. But it is important to note that all metals do not react with bases, and only a few metals react with bases to form salt and hydrogen gas. Second, reaction between a base and acid. So a base and acid react to form salt and water. We have already studied this reaction in the chemical properties of acids. Third, reaction of bases with non-metal oxides. So base plus non-metal oxide results in the formation of salt and water. For example, calcium hydroxide plus carbon dioxide, which is a non-metallic oxide, results in the formation of CaCO3, which is calcium carbonate, and it is a salt, plus water. So now let's see the dilution of acids and bases. So concentrated acid or a base is a base or acid which contains minimum possible amount of water in it. Diluted acid or bases. So mixing of an acid or base with water results in a decrease in the concentration of H positive or OH negative ions per unit volume. And this process is known as dilution of acids and bases. And dilution is a highly exothermic process. So this means that during dilution, a lot of heat is produced. And such an acid or base which is diluted, it is known as and such an acid or base which undergoes the process of dilution, it is known as diluted acid or base. So please stay tuned for the third part of this chapter, acids, bases and salts, in which I will cover the pH scale. Thank you.